The following video will go over the process of creating a script that can be used to automate the uploading of data to an Oracle Cloud EPM Planning environment. We will be writing our script in PowerShell and will be incorporating the EPM Automate tool to perform functions such as running data load rules, downloading files from our environment, and performing import and export jobs. The data we will be working with comes in a comma-delimited file, which contains both the columns of information pertinent to our upload, as well as some columns of information we don't need. Besides designating the specific columns we want from our source file, we will also need to make changes to the column headers, as well as the format of the information contained within the rows of those columns. Following the initial setup, we want the script to be completely autonomous, without needing input from the user, regarding dynamic aspects such as the period information contained in the data load, or whether or not there are new dimension members present that have not been set up in planning yet. To that end, this video is going to demonstrate the following. 1. We're going to set up our planning environment. 2. We're going to create a log file of the processes being run during our script. 3. We're going to format our data file for upload. 4. We're going to ensure that the account members in our data file are in sync with our EPM environment. And 5, we're going to upload our data to planning. As a side note, even though the processes outlined in this video deal heavily with Oracle Planning and EPM Automate, many of the steps specific to the task of manipulating CSV files within PowerShell can easily be tailored to your specific needs and requirements. Some preliminary steps first need to be taken in our environment before we start writing our script. Starting from a fresh environment, we create an entity called Delta Central, which will be referenced in our data load rule. In the planning environment, we need to create the metadata import and metadata export jobs. These will be called using EPM Automate from within our script. In order to upload data, we need to go into Data Management and set up a data load rule. Once in Data Management, we go to the Setup tab. Under Register, there are two options called Source System and Target Application. If you click through these, you will see that there are already a file-based source system and target application set up by default. No changes need to be made to either of these, just take note of their names, as we will be using them in other aspects of the data load rule. Next, click on Import Format. Here we will be describing the format of our upcoming files and how we would like to map them into planning. When working in data management, make sure you save after every change or modification you make by going up to the top right corner of the window and clicking Save. In creating the import format, specify the default file source system and target application. For file type, leave delimited numeric data selected and choose the file delimiter. In this example, our file uses commas. Moving down to the next section, we see rows for our account, amount, entity, and version dimensions. Present in our data file are also information for the month and year. To indicate this, we click the Add button, go down to Source Period Row, and select Year. In our file, this information is in the third column under the column header Date. We indicate that we will be pulling information regarding the month from our file by adding a source period row, choosing period, and specifying the same source column and field number as we did for year. Next, we specify the columns in our data file that contain our account and amount information. For the entity row, we can specify a specific entity by typing the name of the entity into the expression field. We're going to leave the version information as is for now. We quick look at the location and see that there is a location set up that has our import format, source system, and target application set up in its configuration. We go to the workflow tabs and select data load rule. Ensure that your location at the bottom is set properly before clicking the Add button to create a new data load rule. We give a name to the rule that we will be referencing in our script, specify the category, aka the scenario, the rule loads to, as well as the import format to use, the name of the data file, and the directory within the planning inbox where the file is stored. The last step in setting up our data load rule is to configure the data load mapping. Click Data Load Mapping, and for each dimension in the drop-down menu, select the Like tab, click Add, and type in a wildcard symbol for source and target values. This indicates that we want each row of information to come into planning exactly as it's presented in our load file. For each of these rules, we need to also give it a name and ensure that the rule is applied to our data load rule. The one exception to this is the version dimension, which, if you recall, we left blank in our import format and is not contained in our data file. This was to demonstrate that you can also specify this information from here in the data load mapping. For example, if we type BU version 1 here as the target value, then any upload using this rule will be imported using that version and its dimensionality. Once these initial steps are taken, we can get to the business of writing our script. We start by adding a clear script command and a variable for our directory. We change directories and import our data file using the import CSV commandlet. For our log file, we want to get a timestamp of the date and time the script is run. We then insert that timestamp into the name of our log file and write out the start transcript commandlet, specifying the path where we want to save our log file. In the next step, we're going to select the columns we want from our original data file. We're going to rename the column headers where necessary, and we're going to format the data in the rows of those columns. We start by declaring the object variable we want to send the formatted information to. We then take our raw file variable and pipe it into a select object commandlet. In the select commandlet, we're going to have 3 hash tables separated by commas. These are going to identify the 3 columns from the original file we want, how we would like the headers labeled in our formatted file, as well as any formatting needing done on the rows within those columns. To create a hash table, use an @ symbol followed by a pair of curly brackets. Encased within the curly brackets of each hash table, there are 2 components separated by a semicolon, the first component being the name, which will create the header of each column, and the second being the expression. For the name, you can either type out name, or for the sake of brevity, use the letter N as a shorthand. In single quotes, we give a name to our header. The second component within our hash tables is the expression, or the letter E for short. Here, we put another set of curly brackets which will give instructions on what information we want in the rows of this particular column, as well as how we would like that information formatted. For our account column, we simply want the rows from the category column in our original data file. To indicate this, we type the $ symbol followed by an underscore. This references the file object we piped in earlier in the statement. We follow that with a period and the name of the column as it appears in the original file. Next, we add the hash table for our amount column. In this case, the header information doesn't change much, though I am going to capitalize it for the sake of consistency. So, just to recap, the rows in our amount column contain information regarding money transactions. Each entry contains a $, and negative transactions are encased within a pair of parentheses. In order to ensure a smooth upload to our planning environment, we want to remove both the left and right parentheses present in negative transactions, add a negative sign where our left parentheses was, and we also want to remove the $ present in each row. To do this, we start the expression in the same manner as we did with our account columns. We reference the file in the original column name. We then string together 3 replace functions. The first will replace any instances of a left parentheses with a negative sign. The second and third are going to replace the right parentheses and $ respectively with nothing, effectively removing them. Moving on to the last hash table, we're going to create our date column. We create the name field as we did in the previous 2 hash tables, and in the expression, when we call the posted date column from the original file, we can tell PowerShell what type of information this is. So instead of having to find and replace aspects of the text in each row, we instead can identify that each row in that column is going to be a date-time object. Once we do that, then we just need to specify the format we want the information to be presented in. In this case, we're going to go with a 3-digit month and a 2-digit year format, where the month and year are separated by a dash. This coincides with the default period mapping within Oracle Data Management. One last thing we're going to do before exporting this to a new CSV file is we're going to take the first and last period information from the file and store them in variables that we can use when calling our data load rule later on in our script. We create 2 variables called start date and end date, As the data in this file is already in chronological order, all we have to do is approach our file in the same way we would any other array of information. The earliest entry will be in the last position. As we don't always know how long our file will be, we can't simply hard-code the array position for our earliest entry. Instead, we tell PowerShell to work backwards through the array and pick the first row from there. This position is -1 in the array. The latest entry in the array is going to be at the first position, or 0. For each of these rows, we pipe the information into a select object commandlet and use the expand property parameter to specify that we just want the information in the date column in each of these rows. With all that taken care of, we can take our formatted data object and pipe it into the export CSV commandlet, where we specify the path and name of the file we want to create. It's important we add the no type information parameter to the end of the statement, or else we're going to get some PowerShell object specific information in the first row or two of our new CSV file. Now if we run that, we'll see that next to our raw data file, we now have a newly created formatted CSV file, which contains the 3 columns we wanted, neatly named and formatted as we specified. Before we go through the process of uploading that data file, we want to go through and see if there are any account members in our upload file that aren't currently present in our planning environment. To do this, we're going to log into EPM Automate using our username, password, and environment information. We then call the export metadata command, providing the name of the job we created earlier and what we want to call the outgoing zip file. After that, call the EPM Automate download file command using the name of the zip file that was created from our export job. Once downloaded, we unpack the account metadata file and import it into our shell environment. The actual process of unzipping the file is going to vary slightly depending on what you use. In my case, I'm using 7-zip, but there's also an option within PowerShell itself called Expand Archive. So just be aware if you use something else other than 7-zip, this process is going to look slightly different for you. Once unpacked, we can then import that list of account members into our PowerShell environment. Now that we have our account dimension information from planning, we can use that in conjunction with our data load file in order to determine whether or not there are new account members that need uploaded to planning. We're going to create 2 new objects, one representing the accounts from planning and the other representing the accounts that are present within our upload file. In order to get just the information we need for comparison, we pipe our downloaded metadata file and our incoming data file into select object functions. Using the expand property parameter, followed by account, we can specify we want just the rows from the account columns. We then add the unique parameter, which will ensure that our list is populated by only one instance of each occurring account name. We now have 2 lists, one containing the list of accounts in our data load file, and the other containing a list of accounts in our planning environment. From this, we create an object which will contain the differences between the 2 lists. We take our data file list, pipe it forward, and choose from it, using a where object command, only the items that are not contained within the planning metadata list. If there are no new account members needing uploaded, the compare variable will remain null. If we check for whether or not this is the case, we can determine if our script needs to go through the metadata upload process or if it can just skip straight to the data upload. Create an if-else statement where if our compare variable equals null, we simply write to the console that no new members were found and skip to the data load process. Else, we write to the console that new account members were detected and move forward with the metadata upload process. To upload our metadata to planning, we take our compare variable that contains the new account members we need to add and output it to a CSV file in a similar fashion as we did with the columns of our data load file. In this instance, we are going to create 2 hash tables. The first will be for the dimension we are uploading the members to, and the second will be for the parent information. For this example, we are just going to add the new account members as first-generation dimension members. So instead of adding another member as a parent, we will just use account as parent. We then export our CSV file with the no type information parameter. Call the EPM Automate delete file command to remove any old data file having the same name as our current upload file. We then upload our data file and run the import metadata job that we created earlier. We then run a database refresh. Optionally, you can set the database to automatically refresh after a successful metadata import by selecting it as an option in the job creation process. Now that the account information in our planning environment and upload file are in sync, we can move forward with running our data load rule. We call EPM Automate once again and delete any old file that may be present already, containing the same name as our data file. We then upload the file to the inbox in our environment and call the run data rule command. Here we put the name of our data load rule, the start and end date variables we created earlier, the import and export stage options, and the name of the data file. With that all said and done, all we have to do now is log out of EPM Automate and stop the transcript for our file. If we save and run our script, it should go through and complete each process successfully, at which point you can go into your EPM planning environment and validate that the incoming cells of information look correct. And with that, we come to the end of this video. With any luck, you found something useful here that you can apply to whatever automation task you're currently working on. If you have questions or feedback, please feel free to share your comments, and thanks for watching.